So first we'll do the top-down approach for this problem. So in order to do the top-down approach, we first consider the two base cases, which are for step 1 and step 2. So there's only one way to reach the first step, which is by climbing one step. And for the second step, there are two ways to reach the second step, because you can either climb one step at a time, or you can just directly go to the second step. So in code, we'll just write down two if statements. So if n is equal to 1, then we return 1. If n is equal to 2, then we return 2. We can break down the number of ways to reach n step into two categories. So either you reach the n step through the n-1 step, or you reach the n step through the n-2 step without stepping onto the n-1 step. So for the first category, with you being on the n-1 step, like there's only one way for you to go onto the n step, which is stepping up by 1. And then for the other way, where you're on the n-2 step, and you can't step onto the n-1 step, there's also only one way, which is stepping up 2 steps in order to reach the n step. So return climb stairs n-1 plus climb stairs n-2. So now we move on to the bottom up DP approach. So first we would initialize a vector of ints, we'll call it ways. So the number of ways to reach the first step is 1, the number of ways to reach the second step is 2. These are the base conditions, as seen in the top-down approach explanation. And then we'll initialize a for loop with I starting at ways.size. And then we'll continue executing the instruction in the for loop while I is less than n. And we'll increment I by 1 each time. And the reason for this is if you consider the n step, and you consider the size of a ways table, ways vector, then obviously you would need to expand the size of the ways table in order to get the solution for the n step. So you would continue adding elements until the ways vector is equal to size n. So the way to add an element is ways.pushback, and you would just compute the last two elements sum. So I-1 plus ways I-2. And then the last element of the table will be the answer. So for the bottom up DP with three variables, we first initialize these three variables, so I'll just call them int n1 and int, I guess I'll have to initialize it for the correct indentation, int n2, int, I'll just have a int n0 instead. And the reason why n2 is initialized to n1, I guess it just makes more intuitive sense, because n2 is the thing that's going to be computed and returned as the answer. So just makes more intuitive sense this way. You could initialize it to 1, but I just prefer it to be initialized to n1. So in this for loop, we're just going to be continually computing n0, n1, and n2. So like n2 will be the sum of n1 and n0, because those are the last two numbers in the sequence, like if you think of it as the Fibonacci sequence. But yeah, I'll just write out this condition for the for loop first. So int I is equal to 2, and I is less than or equal to 2 plus I. So the reason for this condition is if if n is less than 2, then we don't need to do any computation. So if n is 1, then we could just skip the for loop and just automatically return n2, which is assigned to n1, which is 1. And inside this for loop, we'll just do the computation n2 is equal to n1 plus n0. And in order to like continue on with the sequence, sorta, we'll just assign n0 to be equal to n1 and n1 to be equal to n2. Yeah. And the order of this matters. So you first need to compute n2 because you want the current like computation, and then you assign n0 to be equal to n1 first, because if you just assign n1 to be equal to n2 first, then you get that like, and then you assign n0 to be equal to n1, you get that n0 is equal to n1, which we don't really want. Otherwise, you can't really compute the next correct result. So after this, we'll just return n2, and that's the bottom-up DP with three variables. So for the last way to solve this problem, we'll just use the closed form solution. So the closed form solution uses Binet's formula. So it's this, give me a sec. Well, I guess you can see it right here. This is the Binet's formula. Well, we sort of need to modify it because the Binet's formula is for the Fibonacci sequence, which starts at 0, and we don't start at 0, so so we would just increment n by 1, so we'll just have an n plus 1 instead of the n in the Binet's formula. So we'll just return a round, which returns an int. So Binet's formula is 1 divided by square root 5 times pow 1 plus square root 5 divided by 2 and plus 1, because we don't want to start with 0 in the sequence. And then I feel like after you memorize like the first term of Binet's formula, it's pretty easy to remember the rest of Binet's formula because it's the same thing. The second term is the same thing, except you replace this plus with a minus. So that would be the closed form solution. Yeah, that's it. Thanks for watching. Good luck with whatever you're doing.